Okay, we're shifting from limits for a little bit, and now we're going to talk about something that you should all be familiar with. Find the average rate of change. Well, the average rate of change is just slope. Remember, y2 subtract y1 over x2 subtract x1. But in order to do that, you need to know the two x's, and you need to know the two y's. Well, here they give you the two x's. So the first task, so when x is 0, what is y? When x is 1, what is y? All right? So once you do that, so if you plug 0 into this function, 0 squared is 0, 2 times 0 is 0, plus 1 is 1. When you plug 1 in there, 1 squared is 1, 2 times 1 is 2, 2 plus 1 is 3. All right? And then when you, I think I did it right down here, and then when you put it into slope form, you get the average rate of change, also referred to as slope, is 2, or 2 over 1. All right? That's average rate of change. This would be loosely what the diagram would look like. I have a very shaky parabola there, but I'm right here at 0, 1, and right there at 1, 3, and then I drew a line that connected them, and the slope of that line is what is the average rate of change. In calculus, we move away from average rate, and we concern ourselves with instantaneous rate. So what I mean by that is, let me choose a different color. If I chose, say, let's see, at -4, I followed that up, and I drew instantaneous rate of change, by the way, will be the slope of the tangent line. And the tangent line, remember when you, in geometry, when you have a circle, and the line that just touches the circle in one place, that's the tangent line. The line that crosses through the circle and touches the circle in two places, that's the secant line. Well, that line, when we're finding average rate of change, we're finding the slope of the secant line, and instantaneous rate, we're finding the slope of the tangent line. So if we could draw tangent lines, it would be an infinite number, right? We'd just keep drawing these at any second or millisecond in time, instantaneous rate of change. But for now, average rate of change is when you plug in the x's that they give you to find the y's, and then just plug those points into the slope formula, and that will find the average rate of change. So if we were to do this one right here, yeah, even though that graph would look something like, opposite of 1 is -1, so at -1, there'd be an asymptote. There's a horizontal asymptote here. That's a positive graph. So that graph is roughly looking like this. I'm doing this very strangely. Anyway, but at 0, 1, or when x is 0, sorry about that, we need to find the two y values first. So if you plug 0 in there, 0 plus 1 is 1, 1 divided 1 is 1. Okay, so if this is 1 right here, we're right here at a height of 1. All right? And then if you plug in, I'm sorry, when x is 0, we're at a height of 1. It's right there, that's 0, 1. I'm so used to the parent graph, I almost reverted to that. And then we're going to plug 1 in. Well, that's 1/2. So this point right here is going to be 1/1/2. And then you got it. Average rate, you could even do m secant for average rate of change. Well, the second y is 1/2, subtract the first y, which is 1, divided by the second x is 1, subtract the first x. So 1/2 subtract 1 is negative 1/2. 1 subtract 0 is 1. Well, the slope of the secant line, or average rate of change, well, negative 1/2 divided 1 is simply negative 1/2. And if you look at it, we could, let me do a different color, draw a line going like that and calculate. And if I had a regular graph, it would be down 1 over 2. All right, that is it for average rate of change.